Welcome to the first episode, Part 1 Geology, with Mr. Sabit. A geology word is composed of two parts, which are geo, means the earth, and logos, which means science. That means the science of earth, which is a science deals with everything has a relationship with earth, its components, its movements, its history, its phenomena, and its wealth. The natural phenomena which are explained by geology, Earth's surface consists of continents, oceans, and seas. The continents and mountain chains are extended in a certain direction, while in others we find valleys and plains of different shapes. Seas, some are relatively shallow, while others are as deep as 11,000 meters. Also, we notice that volcanoes happen in certain regions. Some of them become inactive, then suddenly start its activity. Magma released from it, or earthquake causing damage for villages and cities. The extraction of minerals and ores, as well as petroleum and underground water near the Earth's surface or in depth, is known phenomenon used for a long time. And now we are going to explain some branches of geology. Actually, there are many branches of geology. We will explain some of them right now. Physical geology. It is a branch which mainly concerned with the external and internal processes affecting the rock of Earth's crust. So physical geology concerns the external and internal processes affecting the rock of Earth's crust. Mineralogy and crystallography is a branch which is mainly concerned with the study of minerals, their physical and chemical properties, and the forms of their crystal systems. Hydrology. It is a branch which is related to whatever concerns groundwater, aquifers, supply and withdrawal, and use of water in agriculture and land reclamation. So hydrology is related to underground water. Structural geology. Structural geology is a branch which deals with different structures which exist on rocks resulting from the effect of both external and internal forces that continually work with variable degrees of forces on Earth's crust. So structural geology is related to structures and the effect of both external and internal forces. Stratigraphy is a branch which deals with the rules and constants that govern the formation of the layers and the sites of deposition of the sediments after weathering and transportation by different natural factors. So stratigraphy deals with the rules and constants of deposition of layers. Paleontology. It is a branch deals with fossils and the remains of living organisms, vertebrates, invertebrates, or plants that characterize the sediments by which we can determine the geological age and environmental conditions for its formation. So paleontology deals with fossils in rocks. Geochemistry, it is a branch which deals with the study of the chemical structure for minerals and rocks distribution of elements in Earth's crust, and determine the type and ratio of mineral ore in the Earth's crust. So geochemistry deals with the chemical structure of minerals and rocks and the distribution of elements in Earth's crust. Engineering geology. It is a branch which deals with the study of mechanical and geometrical properties of rocks in order to establish the different engineering structures such as dams, tunnels, giant bridges, and skyscrapers and towers. So, engineering geology deals with the study of mechanical and geometrical properties of rocks to build engineering structures. Petroleum geology deals with processes concerning the formation of oil and gas, their migration and accumulation in the reservoirs rocks. So petroleum geology deals with the formation of oil and gas. Geophysics. It is a branch which deals with the exploration of oil traps, ore deposits, and groundwater using physical sensitive sets. So geophysics deals with the exploration of oil traps, ore deposits, and groundwater using physical sensitive sets. And now, what is the importance of geology in our life? Geology prospects for mineral ores as gold, iron, silver, and others. So it searches for mineral ores as gold, iron, silver, and others. Also, discovering the energy resources like coal, oil, natural gas, and radioactive minerals. And searching for the building materials like limestone, shale, marble, gypsum, and others. And also it helps in habitation projects or planning of habitation projects like building new cities, dams, tunnels, and establishment of safe districts from the dangers and disasters. Also, it searches for the raw materials used in many chemical industries like sodium, sulfur, chlorine, and necessary for manufacturers of fertilizers, insecticides, and drugs. Also, it deals with the exploration and the sources of groundwater for the new reclaimed areas. And it helps in the success of military operations. So the importance of geology varies from the exploration and planning and discovering the resources of energy and underground water, and using some elements in the military and in the manufacture of chemical industries. And now, what are the components of Earth? The components of Earth, as we see here, is the lithosphere, which includes the crust, mantle, and core, the atmosphere, the hydrosphere, and the biosphere. Let's start explaining the crust. As we see in the figure here, the crust is the outermost thin shell or the outermost thin layer of the Earth. It varies in thickness, being thin under open seas and oceans. That means the thickness under seas and oceans is from 8 to 12 kilometers, consists of basaltic rocks, which is called sima. Sima means silica and magnesium. And it is about 60 kilometers when the continent consists of granitic rocks, which is called silica and aluminium. The crust rocks are igneous, sedimentary, and metamorphic. Although the difference in density between shale and sima crust is always in what is known as isostatic equilibrium. As we see here, the thickness of the Earth's crust, it is thinner under seas and oceans and thicker under continents. Number 2, the mantle. The mantle forms more than 80% of the volume of Earth's rocks and extends from the base of the crust to a depth of about 2,900 kilometers. It is composed of iron, magnesium, and silicon oxides in the form of solid rocks, except the upper part of the mantle, a ionosphere, with the thickness reaches about 350 kilometers, which is partially molten and elastic rocks, which behave as fluids under certain conditions resulting from pressure and temperature that allow for the spread of convection currents, which permits the drifting of continents above. As you see here, the thickness of the mantle in the figure. Number 3 is the core. The core is the innermost zone of Earth with a radius of about 3,486 kilometers. It forms about 1/6 of the Earth by volume, but being composed of materials with very high density, it makes about 1/3 of the Earth by weight. The pressure that's very high reaches about millions of the atmospheric pressure, and the temperature is more than 5,000 centigrade. The studies that obtained by scientists when they analyzed the seismic waves that spread through the Earth's zones during occurrence of earthquakes helped greatly in determining that the Earth's core could be divided into 2 parts as follows. The outer part, or the outer core, the thickness is about 2,100 kilometers and consisting mainly of molten iron and nickel, and stands under pressure of 3 million atmospheric pressure, and with a density reaches about 10 grams per cubic centimeter. The inner core, the second part of the core is the inner core. It consists of rocks of very high density, about 14 grams per cubic centimeter, and with a radius of 1,386 kilometers. Scientists were able to explain the origin of the magnetic field of Earth may be generated from the presence of outer core that composed of molten material revolves around the rocky solid inner core. So the scientists discovered the main reason for the magnetic field of the Earth, that the outer core, composed of molten material, revolves around the rocky solid inner core. As we see here, the structure of the Earth, or the components of the Earth, from the inner solid core, the outer liquid core or molten iron and nickel, then the mantle, the solid part, and the molten part with the ionosphere, then the crust, which is a continental crust and oceanic crust. Number 4 is the atmosphere. During the formation of Earth's planet, several elements and chemical compounds which were in contact with the molten material remain in their gaseous state, forming later in time our atmosphere, which gets as high as 1,000 kilometers above the Earth's surface. The air density and also the atmospheric pressure decreased as we go higher from the Earth's surface to be low as 1/2 of its value for every 5.5 kilometers till it vanished at higher altitude. The main constituents of the atmosphere in volume are nitrogen 78% and oxygen 21%, and other gases with percentage doesn't exceed 1%. The most important of them is hydrogen, helium, argon, krypton, and xenon, with variable amounts of water vapor, carbon dioxide, and ozone. It can be also noticed that the ratio of oxygen decreases and becomes less and less at higher altitude, which gives human being a state of suffocation at high altitude. During and after the formation of the solid Earth, the component number 5, the hydrosphere, a tremendous amount of water vapor already present due eruptions of old volcanoes had been extremely condensed, resulting heavy rains which fell on land to fill the gaps in large basins had formed on the surface during solidification of Earth's surface, forming the hydrosphere. The hydrosphere includes all the waters of the seas and oceanic basins, rivers, and lakes that cover about 72% of the total surface area of the Earth, including underground water which fill the pore spaces in rocks and soil in the ground. The hydrosphere surrounded the Earth from all sides, forming what is known as sea level, which is an internationally recognized, and all heights of different topographic features are attributed to, such as mountains, plains, plateaus, valleys, and other features that forming the rocks of Earth's crust. Number 6 is the biosphere, and we will study in detail in the second part. Thank you so much for this session. Until we meet again, Mr. Sabit.